Hello everyone. Welcome to the solution of LeetCode problem 2966 named divide array into arrays with maximum difference. Here in this problem, we are given an integer array nums of size n and a positive integer k. Now we have to divide the array into one or more arrays of size 3, which satisfied the following condition. So what is the condition? The condition is each element of the nums should be in exactly one array. That means, suppose our initial array has one element 3. 3 appears only one times. So we cannot put 3 into different sub-arrays. It is strictly prohibited. That means each element of nums should be in exactly one array. And the difference between any two elements in one array is less than or equal to k. Now we have to return a two-dimensional array containing all of the arrays. If it is impossible to satisfy the following conditions, in this case we have to return an empty array. And if there are multiple answers, we can return any of them. So there is no restrictions. Here in the first example, the array contains several elements, which is 1, 3, 4, 8, 7, 9, 3, 5, and 1. And the benchmark value k is 2. Suppose if I divide this array into these 3 sub-arrays, which is 1, 1, 3, 3, 4, 5, and 7, 8, 9. Here, in any of the sub-arrays, the difference of any two elements will not exceed the value k. Suppose in this subarray, 3, 4, and 5, the difference of 3 and 5 is 2. So it is not exceeding the value k. And in this subarray, the difference of the value 7 and 9 is 2. Again, it is not exceeding this value k. So it is one possible output. But in the second example, it is not possible to divide the array which satisfied all of the conditions. So in this case, we have to return an empty list. I hope you understood the problem statement as well as the examples. Now the constraint are here, the array length can be in between 1 to 10 to the power 5. And the array length definitely is a multiple of 3. Because here we have to divide the array into several sub-arrays, and where each sub-array size should be equal to 3. So here the size of the array is a multiple of 3. And each of the array element can be in between 1 to 10 to the power 5. And the value of k can be in between 1 to 10 to the power 5. I hope you understood the constraint. Now let's move on to the algorithm. Now, for the sake of simplicity, we have taken the first example. Here, the array contains 9 elements, which is 1, 3, 4, 8, 7, 9, 3, 5, and 1. Now, we have to divide this array into 3 sub-arrays, where in each of the sub-array, they should not violate the given conditions. That means the difference between any two elements in a sub-array should not exceed the value of the k. For this problem, the value of the k is 2. So here we are using 2. Now the problem is, how can we divide the initial array into the multiple sub-array? So now it is a one kind of sub-problem. Now let us try to understand the problem in a greedy way. Suppose at first, let's assume we have sorted this input array. So now after the sorting, the input array will become 1, 1, 3, 3, 4, 5, 7, 8, 9. Now try to understand or filled algorithm. Here, after sorting, we have to take 3 elements in each of the subarray. So what is the optimal strategy? Suppose we have taken these 3 elements in one subarray, these 3 elements in another subarray, and these 3 elements into another subarray. So why we have applied the sorting? Now, suppose if we take the consecutive value into the subarray, then the chances of the difference between any of the element which exceed the value k will be minimized. Because suppose I take one element here, and another element from here. Suppose, let's assume. So we have taken 3 elements, which is 1, 1, and 5. Now, it is definitely that the difference of this first element 1 and the difference of this last element 5 should be greater than k, or the chances is higher. So we cannot take random element from anywhere, because if we take the random element from anywhere in the array, that means the chances of getting the difference which is greater than k should become higher. So we should avoid this kind of conflicts. So how can we mitigate this kind of situations? So definitely we will try to take the consecutive value. Suppose if we try to take the consecutive value, then the chances of the difference which is greater than k should be minimized, because it is definite that the difference of these two elements 1 and 3 should be less than the difference of these two elements, suppose 1 and 5. So taking the consecutive element for the subarray is optimal for this problem. Now, I hope you understood the basic intuitions why we are sorting the elements, because after sorting applications, then we can take the subsequent element easily. That's why we are applying sorting function here. Now, I hope you understood why we use the sorting function and why we are taking the consecutive elements. Now our problem is, does each of the consecutive elements valid? That means, suppose we have taken this 7, 8, 9, or it is necessary for all of the consecutive element to become valid? Definitely no. That means there may be some of the violations if we take the consecutive elements. So we have to counter this kind of scenarios as well. How can we counter this kind of scenarios? Suppose the main algorithm is we have to iterate all of the elements from left to right, and in each iterations we have to take 3 elements. The first element, suppose name is x, the second element is y, and the third element is z, where x is less than is equal to y and y is less than is equal to z, because they are sorted. Now we have to check whether the difference of the first element x and the difference of the last element z is greater than k or not. If in any of the iterations, in any of the subarrays, if the first elements and the last element of the subarray and their difference is greater than k, that means it is not possible to make this given input follow the given conditions. So here in this case, we have to return an empty list. Otherwise, if these conditions is not true, that means the difference of the value x and z always less than is equal to k, for this kind of situations, we have to simply insert the corresponding subarray into the resultant array. Suppose in this example, we have clearly seen that if we divide the input array into 3 subarrays, then our first subarray contains the element 1, 1, 3. So here the difference of the first element 1 and the last element 3 is 2, which is less than is equal to k. So we can add the element 1, 1, 3 here. Now again, in the second subarray, the difference of the first element 3 and the last element 5 is 2. So which is less than is equal to k. So we can add the second subarray here, which is 3, 4, and 5. And again, for this last subarray, the difference of this last element 9 and this first element 7 is 2. So which is definitely again less than 2, less than or equal to 2. So we can add 7, 8, and 9 into the corresponding resultant array. Finally, we have to return this list. I hope you understood the algorithm. Now let's move on to the code. In this problem, the code is pretty simple. At first, we are given a function named divide array, which has 2 parameters, the input array and the integer value k. Now, we are applying the sorting function to the input array. After that, we are taking a vector of vectors to store the answer, and we are taking a Boolean variable to determine whether a current subarray is valid or not. Now, we have to iterate each of the 3 elements in the loop. Then, we have to check whether the difference of the last element and the first element of any of the subarray is greater than k or not. If it is, that means we have to set the value OK to false. That means it is not possible to divide the given array into different subarrays which satisfy the following conditions. Otherwise, we have to simply make a subarray of the 3 values x, y, and z and insert it into the resultant array. Now finally, if the flag of the OK is false, we have to return an empty list. Otherwise, we have to return the answer vector. I hope you understood the code. Now let's move on to the time and space complexity analysis of this program. In this program, the time complexity is big O of and log n because we are using sorting function. If the size of the input array is n, then the overall time complexity is big O of n log n because of the sorting function. And the space complexity is big O of n because we are using the extra memory to store the answer. Thank you everyone for watching this video. We will get back soon with another LeetCode solution.